In this solution problem, we notice that we're given a reaction. And usually when you're given a reaction, you're going, oh my gosh, what am I going to do? And that's okay. The thing that I want to recall is that if we have a actual equation, 99% of the time you're going to have to use a mole-to-mole ratio. So the most likely reason that you have this equation is so that you can eventually use a mole-to-mole ratio. Okay, well, we need to find a volume. But how in the world are we going to do that? Well, the only thing that I see that looks kind of the same are these first two, because they have to do with the cobalt. And I'm actually looking for the volume of the K2S. So I'm going to begin with the two that look the same. So I'm going to go ahead and start with these moles, because we usually start with moles. Now, I wrote that as a capital M. That's not really going to help me in this problem, right? Because I need to be able to cancel. So I'm going to go back in there and put that as moles per liter. And if you do that, that's okay. We do all make some kind of a mistake at some point. That's okay. Now, to get rid of the liters, I've got to have a volume. But the only volume I see is this one in milliliters. So I'm going to go ahead and start with that. If you can convert it to liters right off the bat, please do that. But I'm going to show you every single step, so that if you can't, you can work it with every step that you need. So then I convert it to liters. So now all I'm left with are moles. So here's where it comes in. We need to do a mole-to-mole conversion. And that's using the balanced equation that you have up here at the top. And we're going 2 moles of K2S, and we're coming from moles of CONO32. Now, what is the mole-to-mole ratio? Well, we got lucky. It's 1. Now, I'm not quite finished because I don't really want moles. I want a volume. And so I'm going to try to attempt to move this. Beautiful. And then I'm going to convert this to liters. So that means it's going to be 1 liter over 0.225, and this is the moles of K2S. So now I've got everything set up, everything cancels, and I'm left with the liters of the K2S. So I'm going to put this in my calculator. And when you do that, you want how many significant figures? You want 3. So your final answer that you obtain should be 0.0894 liters.